If a camera were set up on the satellite, how far from the Earth's horizon will the camera be able to see? Use 4,000 miles as the average radius of the Earth, and they want us to round our answer to the nearest hundredth of a mile. Their hint is to sketch and label the problem first. So as we did before, our first job is to go ahead and draw ourselves an Earth. Okay, we have a satellite orbiting outside. Well, here's a satellite. I'm not sure what they look like, but I'm just going to put a point there. Okay, so this is my satellite. Then we have the center of the Earth here. Okay, so this satellite, it said, was 124 miles off of the surface of the Earth. Okay, that's its altitude. And we also knew that the radius of the Earth is about 4,000. So this part of my line is 4,000, and this part here is 124. They want to know how far can you see towards the horizon of the Earth. So we want to know, if we draw this line here, how far can you see until you touch the Earth? Okay, so notice what we've created there is a tangent line. It did touch the Earth in this one point. And that is what they want to know. What is the distance from the satellite to that point on the Earth where they're viewing? So what we're going to do here is we're going to remember that we have that property that the tangent line is perpendicular to a line drawn from the radius. Okay, so the radius to that line makes a right angle. That was our property that we just talked about for tangents. So we go ahead and create that radius also, because we needed the one that comes straight out and makes a right angle with our line of sight there. Do we know how long that line is? Sure we do. We know that the radius of the Earth is 4,000, so that would also be 4,000. So again, I'm going to draw a cleaned up version of my drawing over here. So what I have basically is a right triangle. I know this is length D. I know this is length 4,000. And this side over here, my hypotenuse, notice, was 4,000 plus that extra 124. So it's 4,124. Now we're going to use the Pythagorean theorem to solve this. Okay, so right now we're going to use the Pythagorean theorem, which we use with right triangles, which remember is that a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. Okay, so don't forget that part. If you hit the wrong parts, it does affect your answer. So our a squared, this first leg, we don't know. That's our distance we're trying to find. So we have our distance squared plus the other leg squared. The other leg was 4,000 equals our hypotenuse squared. That's always the longest side. It's always the side across from that right angle. We're going to go ahead and square those numbers that we have there. I'm going to have to expand again a little bit because that's a really big number. So we get 16 million equals, we have d squared plus 16 million. And again, remember, when you're squaring, that means to take a number times itself. It does not mean to take it times 2. That's how I ended up with 16 million, okay? 17,007,376 over on this side. We want to solve for that distance d. So we're going to subtract 16 million from both sides so we can get d by itself. That leaves me with d squared equals 1,007,376. We have one step left here, just one little step left. Get rid of the squared. To do that, you do the opposite of squaring and you take the square root of both sides. Okay, so that leaves me with just D equals, and I take the square root of 1,007,376, and I get 1,003.68 approximately. Now they wanted it to the nearest hundredth of a mile, which is 2 places after the decimal, so I am good. Right there, 1,003.68 is the distance that that camera could see to the horizon of the Earth.